Okay, so in this video, we're going to go over the simplifying the expression part of the lesson. And for the purpose of this section, right now you don't know where to simplify to, but it's leading up to verifying trig identities, in which case you will have some kind of equal sign over here, and then you know when to stop. But for now, just try to simplify as far as possible, okay? All right, so how do we simplify the expression? Well, you have to apply all your trig identities that we covered in this section. And so sine, right, I could write that as, 1 over cosecant x, right? But that's not really necessary. Let's convert cotangent x and secant x first. So cotan, we know, is just cosine x over sine x. And the reason why I use the quotient identities instead of the reciprocal is because I see that there's a sine x over here. Okay, secant x, of course, is 1 over cosine x. Right? So if you take a look at this first problem, right, these sine x's are going to cancel out. These cosine x's will cancel out. And so this expression just simplifies down to 1. Okay, so moving on over here, right? Sometimes we need to convert things to sine and cosine using our quotient, using our reciprocal identities. Other times we just need to do a simple factoring, right? So between these two terms, right, there's a cosine theta. So if I factor that out, I have 1 minus sine squared theta. And you already know that sine squared theta plus cosine squared theta is equal to 1. And so 1 minus sine squared is just cosine squared, right? So if I substitute cosine theta times cosine squared theta, I just end up with cosine cubed theta. Okay, so this expression simplifies down to cosine cubed theta. All right, moving on. This one looks quite complicated, right? Secant squared minus tangent squared x over cosine of negative x times tangent of x. Well, if you look back at your trig Pythagorean identity number 2, right, we know that 1 plus tangent squared theta is equal to secant squared theta. And so, again, if I just manipulate this, right, secant squared minus tangent squared, that's just going to give me 1. Okay, so this numerator actually just turns into 1. Cosine of negative x, using our even odd identity, that's just cosine of x. Right, and then tangent, we know, is just sine x over cosine x. And so even though this expression looked really complicated, right, what you have over here, what you end up having is 1 over sine x, which is just cosecant of x. Okay. All right, so this pattern should kind of ring a bell, right? This looks like the pattern of a plus b times a minus b. And so a lot of your algebra skills need to be sharp in order to do this problem, in addition to memorizing all your trig identities. Right, a plus b times a minus b is a squared minus b squared. So this is essentially 1 minus cosine squared x, right? If this is your a, that's 1. 1 squared is just 1. If this is your b, cosine of x, quantity squared, is just cosine squared x. And 1 minus cosine squared x, right, that's just sine squared x. Okay, so 1 minus cosine squared x, right? If I move this cosine squared over, that will just give me sine squared. All right, moving on. Now you take a look at a problem like number 7, right? It's like, where do I even begin? Well, why don't you convert cotan to cosine over sine? Tangent is sine over cosine. Now keep in mind, right, some of you might be thinking there's another way of doing this, right? Could I just say cotan is 1 over tan and do it that way? 1 over tan plus tan theta, that works as well. I just want to convert everything to sine and cosine. Okay, now, if I want to add these two expressions, right, I need to multiply this by cosine, I need to multiply this guy by sine over sine, right? This is just like adding fractions, so let's do that. I'm going to have cosine squared theta over sine theta cosine theta, right? Multiply top and bottom by cosine. On this one, multiply top and bottom by sine. I'm going to get sine squared theta over cosine theta sine theta. Now I have common denominators, right? The order of this does not matter, right? Cosine theta is the same thing as sine theta, cosine theta. So these denominators right here are basically the same. I can say, hey, cosine squared theta plus sine squared theta all over sine theta cosine theta. Well, this is your Pythagorean identity number 1, right? Cosine squared plus sine squared is 1. 1 over sine, I'm actually going to split this up here for you even further, right? 1 over sine, I can rewrite, 1 over the product of this is the 1 over the individual terms multiplied. 1 over sine is cosecant. 1 over cosine is secant. And this is another way of simplifying an expression like this. Okay, so you have to know how to, apply your trig identities, and you have to apply the algebra skills. That's what makes verifying trig identities difficult for students. Okay, so moving on, I guarantee you this next problem won't be nearly as long as this one. Cosecant squared minus cotan squared, that's just one of your identities, right? So if you remember, cotan squared theta, what we derived in the previous video, is equal to, plus 1 is equal to secant squared theta. Cosecant squared theta. All right, cotan squared plus 1 is equal to cosecant squared theta. And so if I just do a cosecant squared minus cotan squared, right? That's just going to give me 1. So this is just 2. Okay, so this problem not nearly lengthy as this one. All right, moving on to the last couple problems here, 9 and 10. When in doubt, you can convert everything to sine and cosine. In this case, there's a couple of ways you can approach this problem, right? You could call this sine squared over cosine squared. You'd call this sine squared over cosine squared. And then, simplify the complex fraction. That's definitely one way of doing this. But what I'm going to do is I'm going to split up my fraction. Okay, so I can do this, right? Tan squared theta over tan squared theta sine squared theta minus sine squared theta over tan squared theta sine squared theta. Now take a look, right? These tangent squared thetas are going to cancel out. These sine squared thetas are going to cancel out. 1 over sine squared is cosecant squared. 1 over tan squared, that's cotan squared. Right? And we said that in this previous section right here, right? Cosecant squared minus cotan squared, that's just 1. And so your final answer is just 1. Okay, take a look at this last problem. It's not as intimidating as it looks. You definitely need to know your cofunction identity. Remember, pi over 2 is the same thing as 90 degrees. So cosine of 90 minus x, or cosine of pi over 2 minus x, right, is just the same thing as the sine of x. And so, at this point, you might be tempted, convert this to 1 over cosine, then have a complex fraction. But recognize that there's a sine x here in the numerator. Why don't you just factor that out? And as soon as I factor that out, right, notice I have this term and this term on the numerator and denominator. They will just cancel. Okay, so your final answer in this case is just sine x. Okay, so in this video, it's really just practicing the algebra skills to kind of build up to verifying trig identities. It's critical that you know how to apply the identities, memorize them, and then substitute and then apply all your algebra skills that you've learned.